Chemistry without carbon. Hydrogen fuel cells. The basics of hydrogen fuel cells. There are a number of different hydrogen fuel cells. However, all of them include certain parts: an anode, a cathode, an electrolyte, and for the most part, a catalyst as well. Figure 1 shows the reactions taking place in an acidic electrolyte fuel cell, where hydrogen is broken down at the anode into protons and electrons. The protons travel through the electrolyte system to the cathode, whereas the electrons flow through the external circuit, producing a direct current, DC, of electricity. At the cathode, another reaction takes place, where oxygen reacts with the protons and electrons to make water, which is the only waste product of this fuel cell. Both the reaction at the anode and the cathode use catalysts, as they allow the reaction to be more efficient at creating electricity, and therefore more efficient as a fuel. The first records of a hydrogen fuel cell were in 1838, where a scientist named William Grove had written a letter to the London and Edinburgh Philosophical Magazine and Journal of Science. Within it, he wrote about the development of a crude fuel cell using sulfuric acid solution, iron, copper, and porcelain. In a later letter, he sketched his fuel cell, which is depicted in Figure 2. In 1939, Francis Thomas Bacon developed the first 5 kilowatt stationary fuel cell. In 1955, W. Thomas Grubb started using sulfonated polystyrene ion exchange membrane as the electrolyte, and in 1958, Leonard Nidrach invented a way of using platinum as the catalyst, which was used for both the oxygen reduction and the hydrogen oxidation reactions. The combination of the two became known as the Grubb-Nidrach fuel cell. The company where which they both worked went on to develop fuel cells for NASA. There are many different fuel cells, which are usually determined by the electrolyte they use. The favourite for becoming competitive with carbon-based fuels are proton exchange membrane fuel cells, PEMFCs. This is due to them having a low operating temperature of 40 to 90 degrees Celsius compared to the others, as well as having only water as a waste product. It also has the benefits most others do, with it having a long lifetime and minimal carbon footprint. However, it still has some issues. Both the electrolyte and the nodes use carbon, with the electrolyte being a polymer and the nodes made from graphene or nanotubes. The fuel cell's water must be managed, as the water has to evaporate at the same rate it is produced. This is due to the porous membrane needing to be hydrated, or the reaction will come to a halt. Hydrogen is also very flammable, and as a fuel it can be very dangerous to store. Finally, the costs of making the fuel cells are too much to be competitive at the moment, due to the catalyst platinum being very expensive.